We discuss about the basic properties of wave and how many types of wave are there, what are their properties, and how those waves can generate and how many examples. So that's all are the content that we discussed in our last class. And also we discuss about the amplitude, the frequency, the time period. So we only discuss about the theoretical concept, right? Okay, after these quantities, we discuss about frequency, we discuss about time period, we discuss about wavelength. If we continue with these topics, so
Oh, yeah, we stopped here, I think.
yes. So if we continue with that, so there is a formula which is related to speed of wave. So let's suppose if you want to find the speed of a wave, so for that we have a simple formula to calculate the speed of wave, and that formula will be equal to speed is equals to frequency multiply by length.
Yes. Right. Let me write that down.
Yes, V equals to lambda. So basically represents the frequency and lambda represents the wavelength, right? So this is a formula to calculate the speed of wave, okay? Or wave speed. So in definition, if you want to write a definition for speed of wave, so we may write it as,
Oh, wait, it's speed, and then you multiply frequency and the wavelength to get the speed.
yes. So this is a very simple
Oh, okay.
formula to calculate the speed of wave. Whatever type of wave, let's suppose if we are going to calculate the sound wave, so we use the same formula. If we are going to calculate the speed of light wave, so we use the same formula. So that formula will help you to calculate. Let's suppose if speed and wavelength was given, and we need to find out the frequency. So this formula will also help you to find out the frequency. We shuffle the formula and calculate the frequency or any unknown quantity given in the question, right?
Yeah, okay. I've never used this formula, so I don't know how to use it.
Okay. I will also show some questions related to these quantities so that you will have idea to how to apply all these concepts in the questions, right? So don't worry about that. So basically the distance traveled by a wave each second. Very definition, ask about the definition, but I'm writing just if you forgot something, so you may just
The distance traveled by wave of sound each second.
okay. Okay, one more thing. There is one more term which is very much important. That is wavefront. Basically, when we talk about the wavefront, so by name, we identify that wavefront means the type of like the front of a wave, right? The front face of a wave or the front part of a wave. Because normally when we are going to solve the question, so we are not going to draw a 3D wave or like some 3D diagram of a wave. We are going to draw a straight line of waves in our question. So that's why we need to know about the wavefront, right?
Right.
So basically a wavefront is, in simple word, we can say that it is the shape of a wave, right? Let's suppose if you consider
Oh,
speed breaker on a road, right? If there is a horizontal smooth surface or a road, and there is a speed breaker on that road, so that also give you the shape of wave, right? So that the
yes.
upper part of that speed breaker, that is known as the wavefront. If we consider that speed breaker as a wave, so basically that upper part moving in a straight line, if we move from left to right in a straight line, so that upper part of wave will give you the concept of wavefront.
Oh, okay.
So basically, wavefront will be,
It's like the shape.
Yes, or in simple word, we can say that it is a phase of a wave combined by all points line, right? So consider and count, or if we align all the points, because we discussed in our last class that each particle will vibrate in vertical direction, up and down, right? So those
Yeah.
particles are in a straight line.
Transverse, the particles they vibrate perpendicular,
Yes,
while longitudinal one it goes like in a straight line.
yes. So what we need to do, just we need to combine. Let's suppose if we consider this one as particle one, this one as particle two, and if I join these 2 points, so it will be a
Mhm.
straight line, right?
Yeah.
And same goes with the other part of the wave. So that will give you a clear concept of a wavefront. And when I join all the points, so what will you get in result? You will get a straight line, right?
Yes.
So in normally when we are going to discuss in our questions, or when we are going to draw a wave in our exam or in our paper, so we need to draw a straight line, right?
Yeah.
So that's why it is very much important to consider wavefront. So we are going to draw waves like this.
Okay.
We are not going to draw waves in a form. So we are going to draw waves like this, and let's suppose this wave is moving from left to right, right? So the
Yes.
markers, let's suppose these green lines represents the crust, the upper part, and the black space between the crust represents you the trough, right? So crust, trough, crust, trough, crust, trough. This is the sequence of the wave, right?
Okay. But how can I tell if one is the crust and one's the trough?
Okay.
Like if I have to draw like
Yes.
a straight line.
You don't need to mark, or you don't need to identify each and every crust in the diagram. I'm just giving you a reference that, let's suppose if we consider a marked line the crust, so all marked line represents you the crust, and the space between those marked line are known as trough, right? So we consider trough and crust like this. Okay.
Mhm.
And if we consider the marked line as a trough, so the gap between the trough is known as crust, right? So that is a very simple concept related to wavefront and speed of a wave. Okay, now let's try to solve some basic questions related to the types of wave and the speed of a wave. Then we will continue with the new concept, right? Let me show
Yeah.
you some questions, because that was very much important, that either you are going concept or not. So wave section. Okay, so questions are visible.
Okay.
Okay, so these are different types of questions over here. Now let's try to solve some questions. Let's suppose if we consider the very first question. So the very first question is related to a wavefront. So they are asking for a transverse wave, what is a wavefront? Because in transverse wave, we need to draw a 3D diagram that was very difficult to draw on a paper every time. So that's why we consider straight line. That's why we discuss the concept of these wavefront, the straight line. So uh, first option, a line joining all points on the same crest of a wave, right?
Mhm.
So is it the right definition for wavefront? Because we also write that a line or a
A
phase of
is,
combined by all points.
A is correct.
Yes, because we also discuss with the reference of a diagram that if we combine all the points on the crest, so we will get a straight line or the wavefront. So A is the right answer, right? Okay, let's try to solve some basic one first, then we will do with some difficult one. Okay, question number 6.
So, oh,
Okay, basically they are talking about this one. This there is a ball on a water surface, and it is in a type of a ripple tank. Ripple tank means a tank containing water, and
no,
it begins to move vertically up and down because we discussed that particle will always vibrate up and down position.
and
So
we go
and
over
yes,
the
so
pool.
as a wave passes beneath it, the ball does not move horizontally. Which statement is correct?
Mm.
So basically, you first need to read the answers, then you will get the right one because statements are different. Both energy and water are transferred in the wave direction.
You
Energy is
can't
not transferred.
transport.
Yes. So if you remember in the very first topic, we discussed that waves means only transfer of energy, transfer energy
Only
from one point
energy,
to another.
disturbance.
Yes. So we are only going to transfer energy.
Let's
That's
see.
why ball is not going to move
Let's
with the
see.
wave, right?
Yeah, let's see.
Energy is transferred in the wave.
Yeah, but water isn't. You cannot just transfer water.
Yes, since we are going to transfer water, but we are talking about ball, that why ball is not moving from one point to another. So that is the reason that ball is a matter and matter is not going to transfer from one point to another. So it only vibrates up and down, right? And
No.
same happens with the molecules of water. They also vibrate in up and down position, right?
No.
So C is the right one. Energy is transferred in the wave direction, but water is not.
Woohoo.
Okay, now. Okay, this one is also basic. What is
Let's
frequency of a wave?
um hmm. It's A.
Number of waves passing a fixed point per second. Yes, very good. Okay, yes. This is a calculation part. Question number 12. So basically, I'm writing reading over here. If it is not visible because of watermark, so it is written 13,000 hertz, and this is 1300 meter, and this is 4.0 seconds. So
Hmm.
basically, frequency is given hertz, and 1300 meter is the distance. So
So
let's
you have to
mark
find the wavelength.
yes, because this is the frequency. We know that, and this is simply a distance. This
This
is
is
not
what?
a
Oh, this
wavelength.
distance.
Yes, a simple distance, and this is
Second is what velocity. That's
basically
my
this,
bad.
yes, this distance represents you the wave travels from one point to another. So this is the total distance, right?
Hmm.
So we are having frequency, distance, time, and we need to find out the wavelength.
Okay.
So we discussed the formula that we know we can find with the formula V is equals to F lambda,
Yeah, speed
right?
equal
But
frequency and
yes, but the problem is that we only have a value of F and we need to find out lambda and we are short of value of V. So if we consider the formula V equals to F lambda, so V is lambda is missing, F is given only, right? So first of all, we need to find V because that is very much important. So first we need to find out the value of V.
then we can find out that.
Yes. So any idea with the help of other values, can we find the value of V?
Hmm,
Okay.
I can't. I don't have an idea.
Okay. Okay. Do you remember the basic formula of velocity or speed in kinematics or in motion? If you remember,
Um, the
V is equal,
kinetic energy is
no, no,
E
only related
half
to,
of this.
yes, that was right, half mv square, but that is for kinetic energy. If we are
No,
talking about kinematics like motion, so in motion, what is the formula for speed or velocity? Is it v
I
equals
don't.
to distance upon time,
Oh
right?
yeah.
Yes. So that is the basic formula. So in simple words, we can find out the value of v by using this basic formula. So d is equals to 1300 meter divided by 4 seconds.
Uh, uh,
So you just simply divide 1300 by 4.
okay, so it's
So you are getting 325. So basically 325 meter per second is the speed. Now you can easily find out the value of wavelength.
okay. So we use that. We
Yes,
use 3.5 for velocity,
yes,
and then we divide it with frequency.
yes.
I don't know.
Now we already calculated the value of V 325 meter per second, and we need to divide it with the value of F, that is 1300.
Okay.
Okay, so we are getting answer.
0.025.
Okay, so that is option
Okay. I did the work.
A.
Yeah, it's A.
Okay. So in this way, you may also use that formula, right? Because sometimes they trick you by giving an unknown value. So first you need to find out that value. Then we use our original formula, right?
Yeah.
Mm, okay, this one is also related to the formula of speed of wave. So try to
Okay.
solve this one.
You have frequency, but no speed and wavelength.
Yes. Now they are asking which pair of value of speed and wavelength is possible. Basically, they just give you the value of answer and you need to find out the value of data, right? So this is a reverse type question. Because frequency is given and we consider frequency as the final value of our question, and we need to find out the original value of the questions.
Oh.
First of all, because we know there is only one formula, V equals to F lambda, right? And we know frequency is given. So basically, if we shuffle this formula, so we will get F equals to V over lambda, right? So
Yeah.
now one by one, you need to substitute the values. Like for option A, we are having value of V. This is V and this is the value of lambda. So 330 divided by 0.33. So you need to divide each and every set of values. So if you will get 10,000, 10K means this means 10,000 hertz. Simple words, 10 kilo thousand. So 10
Oh.
value. So you just need to divide the value. So you will get the answer 10,000. So that will be our final pair. So this is
Oh.
for value B, 330 same goes for option C, same goes for option D. So which option gives you the value 10,000?
Mm. Okay, right now. First one does not give me that, it gives me 1,000.
Okay, so
Second
first one
one,
is not correct. Okay,
no,
try.
it's not. Right. 330 divide 33 gives the second one, it's 10.
Okay, so second one is giving you a value 10.
Yeah. The third one, I still need to check. 3
You need to
multiplied.
check the value because you are only getting 10. We need to find out 10,000. Okay, so
Hmm.
also,
The 10 to the power 8, right?
yes, 3 to the power 8.
Okay. It's gonna be 300 million.
You just need to write 3 and 8 zeros. If
Yeah,
you
yeah,
are not,
80.
yes, if you are not having scientific calculator, so you may just write 3 and 8 zeros
Yeah, just doing that right now.
divided
And
by
then
30. We are getting,
and B, I'm not sure.
yes, we are also getting a greater value than 10,000, right?
No,
So that is also not possible. So definitely it would be option D, right?
I just calculated it like again to make sure, and yeah, it's B.
Okay. So now you got how to calculate the value, right?
Yeah.
Okay.
Okay. Then.
Okay, question number 17. Identify which, what is the example of longitudinal wave?
Okay. Which of the following travels as a longitudinal wave? Hmm. I mean, it has to go on a straight line. It's parallel.
Okay. So basically, you need to find out a straight line.
Um, see? Oh, I know, it's shaken from side to side. No.
Okay, so basically a radio wave in air, a sound wave in a solid, a wave on a rope shaken from one side, an infrared wave in space. So basically a radio wave is something different from sound wave, right? Because radio wave are electromagnets, so they are not going to move parallel in air. So radio waves are not possible.
No.
Okay. So we know that sound
And
always travel in a straight line. So basically a
yeah,
sound
some
wave
of
in a solid, right?
yeah.
Okay. Try this one also.
Mhm.
Basically, the diagram shows a ball floating in a tank of a water, which diagram shows the movement of the ball as the wave passes.
Wouldn't it be like the fourth option D?
Yes, because we know that a ball will always vibrate perpendicular to the wave.
Yeah,
So D is
like
the right.
vibrating up and down.
Because once it got up, so in next moment it must go in downward direction, right? Because
Yeah.
when wave pass through this ball, so ball will again come to its original position in downward direction. So D is the
Yeah.
right choice. Okay.
Mhm.
Are you getting question easy or difficult?
I think that one with using the formula seems difficult because I'm not good with formulas.
Okay. So let's try this one. Now this question contains diagram plus formula. So first go through the question, then I will tell you.
Just mhm. Hmm. So But I don't understand the question.
Okay, so basically, first of all, there are two types of graphs. One graph is between two quantities, that is displacement and distance, right? Basically, displacement gives you the amplitude, right? This shows you the amplitude, so ignore that. This also shows you displacement that is related to amplitude, so ignore that. Important thing is on x-axis, time and distance, right? Okay, so first of all, if we consider graph number one, so graph number one gives you only a distance. So by mean of distance, we can easily find out the wavelength, right? So from first graph, we are going to find out wavelength, lambda. And from second graph, which quantity you need to find out?
See? Distance. I don't know.
Okay, so first of all, in question, we need to find out the speed, right?
Oh yeah.
So that's why we need to know about the frequency and the wavelength from the diagram. So lambda can be extracted from the first part of the graph that shows you the distance. And what is the definition of the wavelength, or how you are going to find out the wavelength from the graph?
Yeah.
If you remember the basic definition, so the basic definition is the distance between consecutive crust or consecutive trough, right?
Yes, yes.
So we just simply mark over here. So you may find out by crust or crust, or in simple word, you know that one crust, one trough makes a single wave, right?
Yeah.
So this is a complete wave. So it means that wavelength is equals to 2 centimeter. Length of a single wave is 2 centimeter, right?
Yeah.
And if we consider this value, this will be 0.5. We know between 0 and 1, it will be 0.5, and 2 and 3, it will be
This is
2.5, right? So 2.5 minus zero point 0.5 will be equal to 2.
yeah.
Okay. So we find out the value of lambda. Now from the second graph, we need to find out the time to complete one vibration. This is the time for one wave, right? So in how
Yeah.
many seconds wave is going to be cover its whole distance? 0.04 second. So this is the time period, right? Capital T. So capital T is 0.04 seconds. Final thing is basically this question is a typical type question for you in starting. When you go through the topics and practice the question, so you will get the concept. So we know the formula V is equals to F lambda, right?
Yeah.
And we need to find the value of F because V is already asked in the question, V is unknown. And we need to find out the value of F because that is unknown also in the formula. We get the value of lambda from the first graph, but frequency is missing. So to find out the frequency, we use a relation of frequency and time period. Frequency is always inversely to time period, right?
Wait, what's the I for?
That is actually one, that is 1 over t.
Oh.
Frequency is also equals to or inversely proportional to time period. If we increase the period, frequency will decrease. Or if we increase the frequency, time period will decrease, right? So you just
Oh.
simply find out the value of frequency from the formula of F equals to 1 over t. So F will be equal to 1 divided by 0.04. So that will be the value of frequency, 25.
So it's
We are
one.
getting 25 hertz. 1 divided
Oh,
by 0.04, yes. So we will be
yeah.
equal to 5
I got the full answer.
50 centimeters,
Yeah, I got 50.
because graph is mentioned in centimeters and answers are also given in centimeter. So 50 centimeters
Centimeters
per
per
second.
second.
Yes. Okay.
Mhm.
Okay, so these are some basic questions related to the quantities and related to the basic formula of speed of wave. Any question, any confusion?